you want to create your own lab, okay, during the course studies, or you want to create your own lab, there is a simple option. Just click on add new and you can create something like BGP, MPLS, and you can add this. Okay, as soon as you add it, you get a empty file UNL. Now you can add number of nodes that you want. Let's say you want to start with some routers. Okay, let's say you want to add five, let's say 5 devices. So enter 5, save. There you go. Now let's say you wanted to label it. Okay, just place them in some order. So let's say this is your P router, this is your P1, this is your P2, this is customer end 1, customer end 2. So to make the connectivity, you can just drag drop. You have one connectivity over here. Similar way, you got another connectivity which goes from this to this. Then you have this connectivity, right? And let's say you have this connectivity. So I'm just showing you how did I design those workbooks and how much time it takes to create them. So let's say this is one of your region. For end PCs, you can have a very small VPCs, or even a router is okay. You can just add two VPCs here. Okay, and shift it bit on the left side, because you also need those console to on your right side, so that you can always refer the IP addressing, right? So how do you place any IP addressing on the screen? Because you can't keep on flipping to and fro for all this IP addressing, site ID, and all those things. So you need to keep your IP addressing as well on your screen. So let's say 192.168.23.1/30. Okay. So let's say this is somewhere over here. Or you can first duplicate all these things, and then all sudden you can just change, modify, and drag it to the right place. So let's say this is dot one. Let me add it on P side. So this goes here. Then I have, let's say 34.1 over here, 34.2. So when you lab anything, keep all the information on the screen. Otherwise, you will end up referring too many screens. Okay. And let's say something that you want to configure between P2 and P1 and C1. So let's say 17.5.7.1. Need some more here. So this would come here. So similar way, let's say this is dot 2. Keep it here. 27 would come here. 27.5.7.2 would come here. Okay. So this way we do the needful configurations, needful IP planning first. This is provider end. One. So normally called CE1. Let's say this is India. Let me take a duplicate of this. And this is customer N2, C2. Let's say this is okay. This is the provider end, basically your ISP, core ISP. Correct. This you can increase the font depending upon. Okay, now since you have all this configuration, you can start preparing your configurations as well as to power on these nodes. What you can do is either you can go one by one, or you can select like this and also just power on all the selected ones. So it takes some time for them to spin up, and within 10-15 seconds they will come up depending upon your system RAM and the CPU that you have it. So if you are running on a shorter resource, then get them up one after one. If you are running on a server, then you can select all and power them on all at once itself. Okay. So meanwhile, what we can also do, we can take one notepad and you can start configuration of the BGP initially. Okay, so that it will be later helpful for you to directly take the config and paste it on the device. Go ahead. Sorry, go ahead. Any question? Okay, see, you can see here. Now, which is P1, P2, P3. So what you need to do is first, while you bring it to the topology, there might be they not with the standard name. So you can just rename them with the help of templates. You can just say that this is P1, P2, P3. Let's say this is P2. This is C1. There you have C2. Okay, now it will be for you to refer it. So if you have P1, you can just see the interfaces. So you have gig 0/1 and gig 0/0. You can just configure it as interface gig 0/1, IP address 192.168.23.1, 255.255.255, let's say 252, no shutdown. Interface gig 0/0, IP address 17.5.7.1, 255.255.255.252, no shutdown. Okay, basic interface configuration. Then you go with the provider core. Then what interface does it have? Interface gig 0/0, no shutdown, IP address 192.168.23.2, 255.255.255.252. Then go to the next one, which is interface gig 0/1, no shutdown. Then IP address configuration 192.168.34.2, 255.255.255.252. 252 is /30, where you have two usable IPs, and four IP, two usable, one network IP, one broadcast IP for /30. Then you have PE2 interface 0/1, IP address 192.168.34.2, 255.255.252, no shutdown. Interface gig 0/0, which is no shutdown first, and then IP address 27.5.7.1, 255.255.255.252. Okay, so this is the interface configuration here. You can also make the loopback configurations too. So let's say you wanted to have some loopback configuration, the software interfaces. So IP address to 2.2.2, 255.255.255.255. We can just copy and paste on the different devices. So let's say this is P. For P, I'll keep it as 3.3.3. Here I'll keep it as 4.4.4. And for C1, let me keep C1 as 1.1.1. And I have one physical interface, which is gig 0/0, pointing to P1. And this IP address is 17.5.7.2, 255.255.252. No shutdown. CE2. Okay, I already have put the label here. So CE2, let me keep it as 5.5.5. And this becomes 27.5.7.2 and 255.255, no shutdown. Okay. So now we have done the interface configuration for all this nodes. Okay, all these nodes. We have also done the loopback. What else you can do is, let's say if you form eBGP here, and you're basically running some sort of internal routing protocol like OSPF or ISIS, okay, or EIGRP. So all the internal routes will be propagated and would be known to each devices, all the different loopbacks that the service provider has it, right? And also you can enable the MPLS tags here. So when you enable the MPLS tag, you can see that the prefix that is being entering inside, they would be tagged with the MPLS tag. So like let's say a tag of 17. And when they go from one MPLS router to another MPLS router, the tag will also get changed from 17 to let's say 18, then come over here, and at this time the tags will be removed. The process is called pop. Okay. So these are the MPLS states where the tags will get added up, get swapped here, and then get popped. Pop means remove, and then it will push the prefixes. So like this, the configurations are done. So as of now, I'll just show you the BGP configuration here. Let's say if I add BGP configuration on CE1, let us decide some autonomous system for this. So let me call this the provider end as AS 65,000, and let's say the CE1 is 33,000, and CE2 is let's say 55,000. So you can just place it somewhere here. C1, C2, let's go here and let us configure this part now. So CE1 router BGP 33,000 neighbor, right? So who is my neighbor? 17.5.7.1, and he belongs to the AS 65,000. Okay. Do you have any network to advertise on CE1? Yes, you had one network which you wanted to advertise. Similar way, CE2, you can also take as a reference and manipulate if you don't want to write every time. So you can have 55,000, you have 20 from here, 27.5.7.1, 65,000 network, and you can advertise 5.5 here. And from the P1 and P2 side, so for P1 and P2, you can just take the reference from here, and this is AS number 65,000, 17.5.2, and the AS number is 33,000. And the network advertisement, let's say, is 2.2.2, right? And P2 router BGP is this, neighbor is 27.5.7.2, remote is 55,000, and network you're advertising would be 1, 2, 3, 4, 4.4.4. Okay, so like this, you need to make the config, and then you can just bring it to the console of this. So let's say we start with P1. You can double click on the console, and there are two ways that you can copy paste it, either via HTML console or a regular putty session. So you can go with either of them. So let me show you the HTML part. So let's say go inside the conft and paste it. You can also give the host name so that it looks good and clean. Let's say if you have this, so see now you can see the host name is reflecting P1, and similar way go with the core conf t host name P, paste the configuration, then go with the next one which is P2. Let me just add the host name here, PE2. Okay, I'm just showing this so you know how the lab and how the configuration should be have to made in inside the lab. Host name C1, copy this, go to C1. Okay, now since you're adding only interface, it may not come up the BGP session. It will come only once you add those BGP configuration. C2. Now we will add our BGP configuration. And if in case you need to see the packet capture, then there is an option to also take the capture, and it will show you the BGP packets and the different TCP handshake that it does initially. Okay, all those things. One second. Okay, this is how the Wireshark look. Now I'm going to copy the configuration that we made it for C1 first. Then go to C2, P1, P2. See, do you see this? So first you need to understand what happens at the time of BGP. So as you know, BGP is TCP 179 protocol. So as the TCP comes, then the first thing is three-way handshake gets successful, and then only the TCP messages or packets start flowing to them. Okay, TCP or I can say that BGP packets or messages. So from this diagram, you can see here the SYN pack come first, SYN message, then you have the SYN ACK. See, this is the message here. SYN, SYN ACK, and acknowledgement. Three steps. You can see the sequence number, also sequence, and the source port, sequence number. Okay, sequence number. See the acknowledge number, and you see that gets added up and sends it back, right? So how the SYN act happens? So if a source send a SYN pack with a certain sequence number, then the destination is going to reply back with SYN act with stating x equals to 2 and y equals to 1, and the source is going to send the acknowledge with y equals to 2. Okay, this is three-way handshake. Once the three-way handshake happens, then you will see the BGP packets like open message. See, do you see the open message? Then comes the BGP packet. Then you have the different BGP messages comes into picture. Keep alives are there. And if it exchanged the database, then you will see some update packets and other type of BGP packets. See, you have some update packet here, update messages. So where they're sharing their database, right? And if you go to the device now, let's say you're on the C1 and you want to check the BGP status. So you can first check the neighbors. This is going to give you a detailed report. You can also check the summary of the neighborship. So you have a neighborship now since 2 minutes. They are up and running fine. If you would have received status like idle or active, then that means this neighbor is down. You're not forming neighborship with that. This is BGP version 4. This is the AS number with that remote device. These are the messages you sent and received. This is the table version. Input queue and output queue are 0. There is no queuing happening. Uptime of the neighbor is this. You are learning one prefix from there. What prefix are you learning? Also, you can check under the neighbor command. So if you go with show IP BGP neighbor, it may not give you the exact detail, but there is one more command to find the prefixes. So that is called show IP BGP received routes. So there is one route that you are learning as of now. Okay, 2.2.2 because you have assigned the loopback and you are advertising that network. Okay, you are right now over here. And 7.1 because that's the physical interface IP of that PE1 where you're forming the eBGP. And this is the network that you're advertising. So it says that you're learning this network via this as a gateway. So this is a gateway now, and this is your destination or the prefix that you're learning. So this is the prefix it was showing with number one. That means one network you're learning. If you would have multiple network that you advertised, then it would be showing like four prefixes learned or five prefixes learned. See, this is also a command which is highly used in the production. Uh, if in case you want to know how many prefixes is this sending to you, okay, or you're receiving it from here, you just have to enable one command or one configurational line inside your BGP process. So once you do that thing, then it will show you like what prefixes are getting learned from that particular neighbor. So what I'll do is I'll go to that BGP process, router BGP, okay, and you have the statement 17.5.7.1. soft reconfiguration, inbound, enter. See, now this command will show you that which prefixes that you're learning from your neighbor. So if in case you're here and you want to know what all prefixes is that you're learning from P1, so it will show you clearly that the different number of prefixes that you're learning from there. Okay, that is nothing but when you do show BGP summary, you get this information, right? This information. So if a interviewer will ask you what is the meaning of this, I'm just going to add some more to P1 and advertise it. Let's say I have loopback to IP address 10.10.10.10 255 255. Okay, one second. Similar way, let's say interface 3, IP address 11.11, 255. Okay, and let me add these as a network. Router BGP 33,000. Okay, sorry, this is 65 here. And I'll just add them as a network. So I have added 10.10.10 mask of 255, 255, 255, 255, and I just added one more LAN unit. Okay. Now if you go to C1,
You'll have three.
see now you can see the increment. Okay. And if someone asks you what are the meaning of prefixes, what is that your prefix that you're learning? Do show run section BGP. Yeah. Now you have three. Okay, the update message got synchronized. You have three. You have the access, so you can see it. But if someone asks you from C point of view, what is the three and how do you find this out? So this command is the easiest command to see those prefix that you're learning. Okay, so you have 2.2/32 from next gateway. This is AS path that got appended. Wait is 0 because for all the external eBGP routes, you don't get wait. Wait is only for iBGP. And internal routes, uh, you have 10 series, 11 series, and this means the best path as of now. Okay, best path. And from the show IP, BGP, or IP route, you can see three routes being learned. Okay. Show BGP summary. So if in case for any reason if this goes down, okay, what will be happening to your routing the BGP summary table? Let me show you. If in case you suspend the link, just go here and suspend the link. So when you do the suspend of the link, there is the whole timer by BGP 60 second, 180 second. So it will wait for 180 second and then it will say as the states are idle state or active state. Okay. So it's going to wait for a certain time and then declare the neighbors are down or not reachable. And then you will see this timer into a different states. So 180 second means almost 3 minutes. So that much time it will take for it to declare. You can see here it shows the timer. So last it read is 1 minute 32 seconds. So this is in seconds. Seconds means this is 3 minutes and this is 1 minute. BGP version 4. As of now, it was established, but since you have suspended the link, it's going to get removed those neighbors. See now this last read has increased to 2 minutes. Okay, so just in few seconds, then it will declare the message saying that it's dead. The neighbors are dead, and it will take it out from the routing table. See, so do you see that it has taken out? Whole timer expired. The neighbor is down, and so on. Now, if the interviewer will show you the same command, not this one, summary command. See, do you see the state now?
Idle.
Yeah. So this is what will happen. Okay. If you see idle state, that means there is no active neighborship. To have an active neighborship, there must be some indication of any number showing as a prefix that is being learned. So now it's saying down since last few minutes. So last down for 55 second, 1 minute, and state is idle. That means you're not learning anything. And also that receive route, if you check, so you're not learning anything. The prefix learned is 0. Okay. So like this, we do the case study and we lab it. We see what happens when you bring down, what happens when you add something. And that is how the topics are done, labbed it, and prepare the notes or whatever you want. So the more you lab it, the more you get the core of it, and it helps you in the CCI and the rest of the part.
Yeah. This
Okay.
is very good. This is very good for me also to recap because I also troubleshoot the BGP almost every day, and we
Okay.
have a lot of flappings happens when neighbor is not communicated. We don't receive the neighbor from the other routers. So this
Okay.
is very good. So
Yeah, correct. Yeah. Okay. So I have a small presentation, basically a roadmap, you can call it as. The class would start from the next week. Timings are as of now, what as per your time zone. So 6:30 to 8:30 here in India. This is enterprise track. though we have different tracks that we are starting. So we have on other side the security track, which is starting next week. We have the automation course, which is starting next week. We have some firewall modules, which we are starting next class. We have VPN firewall mastery, which is VPN mastery, that we are starting next week. Okay, so don't be confused uh which track this is going to be as per need as per your need. So as of now, I'm going to showcase something for enterprise. And along with this, I am also planning to launch another track, which is specially for SD-WAN, ICE, and DNAC. Okay, so I'll give you some pointers about this as well. SD-WAN, ICE, and DNAC. I'll show you how do we deploy this on the EXI, especially the DNAC part or the SD-WAN and the Cisco ICE on the EXI if you're running EXI or VM workstations, and how do you basically use it in the production for the device onboarding or upgradation or the config push or writing the template on the DNAC template hub. So various things that we can do as a DNAC as a use case. So there are a lot of modules. To avoid any confusion, let's stick with enterprise as of now. And the subset of these are SD-WAN, you got DNAC, you have Encore, you got NRC, right? And you will have finally the CCIE Enterprise Practice Bootcamp, where we will do the ticket-based scenarios. All right, so this is how the module of enterprise would look like. So I also have, let me show you. If you want to go through the modules, then you can check it over here.
Sagar, I have one question.
Yeah, go ahead.
All this model, it will be teaching by you or
Yes,
what?
yes, correct. Yes. It
Oh,
will be,
okay. Then
yeah.
for I am interested, and if it's all will be taught by you, then it's okay for me.
Okay, yeah, sure. So these are the five module listed: Encore, NRC, SD-WAN, SD Access, basically DNAC, and CCI Enterprise. So to get started, let me just go through the module first: NRC, and Auto, SD-WAN. And as you all know that we would be providing you the lab and the lab access for with each module. So first you get the SD-WAN access and then the rest of the modules. So as you know, the CCNA track, which is 200301, and then comes the CCNP Enterprise, which has two papers, Encore, and you can opt any one from the concentration, either NRC or SD-WAN or SDA or N Auto. Okay, or there is one design paper as well. And then those who are preparing for CCI Enterprise, for you guys, this is the mandatory written paper. And then comes the 8 hours of lab. If in case you're preparing for this, Or if you're just looking the training from the upskillment, then that's totally also okay. Again, depends person to person, what is your need and ask here. So if someone wants to go through the module perspective, then we are going to cover NCore, NRC, SD-WAN, DNAC, and the blueprint coverage of CCI EI. So these are the modules that we would be covering. Okay. So from the overview perspective, this is going to be 5 to 6 month duration, and the timing would be 6:30 to 9 p.m. India. We'll start with Encore initially, and then we move to NRC. Then we go to SD-WAN, DNAC, and then CCI EI bootcamp practice. So each module would be a month or more. So the Encore NRC will take almost 2 to 3 months, whereas SD, WAN, and DNAC would take another 2 to 3 months, and finally around 2 months of CCI bootcamp. So together, almost like 5 to 6 months of duration, and as I told you, it's also only a weekend program, because most of you guys are working professionals, so may not be weekdays feasible. So weekend is only the opportunity where most of the people can join the session. Okay. Coming to the lab, we will provide you two types of lab. One is the remote access lab, and second one is the home lab setup. So remote access lab, you will almost get for each one of it. Say for example, you get a 6 month over here, you get a 3 to 4 month over here, another 3 to 4 month over here, and another 3 to 4. So altogether, you can just consider more than an year. Okay, more than an year. With respective to home lab, it's your own system. If in case you have your own laptop or server, we will help you to deploy on that machine as well. So each one will have its own specification. Encore and NRC can work between 16 to 24 GB of RAM with 8 core CPU. SD-WAN needs bit more. You need up to 30 GB RAM. DNAC need very high. I'm going to show you how much it's gonna take it. Never possible, impossible in a laptop. You must have a server to run this. And for this, you need again 64 to let's say 128 GB, 64 GB to RAM. Okay, just 64 to 128 GB RAM with minimum 8 to 12 to 16 core of CPU. Okay, so this is from the home lab perspective. Again, as I said, if you don't have that big laptop or server, we always have you remote access. You can connect it simple via MSTC SC, or we also have another platform called Gokomole. So you can connect it via either of this option. Okay. So that is about the roadmap, the remote and the home lab setup. Uh, Coming to the modules, as you know, we will cover the blueprint, official blueprint. So no doubt you can take it directly from the Cisco website. So someone who doesn't know where to get it, just go and search Google for, or you can just go through this link as well. So I've already kept all the blueprint. So it's already available on our website. So you can find all the modules and the topics listed under this. Okay. And someone who is attending this demo CCI batch, I definitely know you guys know where to get, because this is not something like CCNA level that everything has to be spoon fed. I believe you know how to take the Cisco Enterprise training PDF. So this is the complete roadmap here. Training catalog. Select enterprise. So there it comes, SD-WAN, Catalyst Center Foundation, Encore, NRC. Okay. So these are some topics that is going to get covered. Okay, let me show you, in case if you don't see my screen, let me share my another screen. As I was, do you guys see the EXI page of do you guys, what do you guys see?
Yeah, yes. Yeah, I can see.
Okay, so DNAC comes under SD access. Okay, so DNAC would come under SD access, and you can see the resource that it needs. It needs almost 32 CPU with the memory capacity of 256 GB. This is the RAM size. This is the CPU size, and this is the storage that it needs. So close to 2.5 TB. So this may not run on your machine, but still, if you have, if you need, if or you want to try on your server, I have the file. It consists of 40 GB file. I'll show you the deployment on the EXI server. How do you get the dashboard, and how do you onboard the 8,000 devices? How do you do the software upgrade from the DNAC? As well as how do you push the configuration, and how do you integrate with Cisco ISE and DNAC controller. So under the DNAC module, I'll show you the whole setup of process. Okay, so that is about the DNAC. With respective to other modules, we have different labs. Like for an example, this is one lab for Encore NRC. So I'm going to just show you a few options here. So let me just maximize the screen size. So you can see this. This is this is going to be our major topic for routing switching. And let me tell you the blocks that is going to get used here. So let me just put it down. So this is the place is this is the place where will static routing. This is the place where we would do the VPN topic discussion, the different VPNs like DM VPN and GRE, IPsec. This is the section where we do the BGP. For BGP, I have kept different scenarios. So these are all different topics and scenarios for BGP. There are some more at the bottom here. So this is also for BGP section. This is BGP. This is BGP. And over here on the topmost area, we do things like um, the HSRP, VRRP, GLBP. Okay, and here we do the reflector. Over here, we would do NAT, ACLs. So this is a lab where you do almost all the protocols from the CCNP point of view. Okay, a very massive lab basically, and the workbooks are already with us. Let me show you how the workbooks look like. So this is how the workbooks look like. It's a lengthy workbook with 300 to 400 pages. So you can see, say for example, you start with, okay, let me take somewhere in middle. So let's say you go to the BGP topic here. Let me click here. So this is how the lab workbook would look like. You can spin up the lab either on the remote side or home lab, spin up the nodes and start reading the task and start making the configuration. So if you want, you can first refer and practice it, and once you know the understanding, then you can erase those nodes and then once again reconfigure with with your own set of knowledge that you have learned it. Okay, so these are task based basically. So configure basic BGP lab. So you have the task given, and this is the section. So what do you see from the diagram? So basically, this is a eBGP. This is IBGP. The task will say that do the loopback eBGP. It will say that do the multi-hop connectivity. Then it will say that update the source. So you know the 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 BGP initial configs that you want to learn. That is what this is talking about. And also it is going to give you the validation because that is very important. After configuration, what type of commands you must input and what type of output are you expected. And out of that output, what is important to observe. Okay, just getting output is not sufficient. You should know what is the right output that you get from that. Okay, and the meaning of that show output. Say for example, if the interviewer will ask what is V stands for, what is this stands for, what is table version stands for, what is input queue, what is output queue, what do you understand by this, right? So you should know the meaning of that. So if you see here the state, if your BGPs are stuck on either active or idle, then that means your neighbors are not up. They must be running with certain timers to show that your neighbors are up since 12 minutes. If for any reason it show active or idle, that means this is a down status. So you should know the basics first to go to the CCI level. You can't straight away jump into CCI level to and then not know the basics behind it. Same goes with BGP table. When you open up BGP table, you will find all the routes. So the interviewer can ask you like why it's showing this, or why it's showing 32768, or why the weight is showing 0 for some route. What is local preference? What is I stands for? So this is where the explanation is. So if it is showing 32768, that is because it's a internal found path. If it is showing wait 0, then it's an external route found. And this is the AS path that is getting added to this. Okay. So that is what happens. Here you don't have AS path. The reason is it's a IBGP prefix. Similar way you go to BGP routing table, the interviewer can ask you like what is B stands for, which is very common. Even a CCNA person can do it. But what is this stand for? What is this stand for? How you troubleshoot it, right? The different meaning of this. What is this stand for? What is this stand for? So the explanation is all over here. So 20 stands for eBGP AD value, administrative distance value, right? And the debug message of it. The debug, what happens, the different BGP states here, open send, open confirm, established, up. So it's a very detailed workbook. So then comes the next task. See, this is another task where you are going to make a role change. You're going to make a device act as a passive and the other one act as a as a active. Okay, so BGP also has a concept when they are going to make two peer routers, active and passive. Manipulate the BGP timers. You can manipulate the whole timer, keep alive timers. See, as soon as you make these changes, 60 and 200, you can confirm it in the Wireshark. So this is a capture which I took it from the Wireshark. So Wireshark will reveal that the changes that you have done it. Okay. Then comes the next hop self. Let me take some more pages ahead. Yeah, so this is the section covering BGP's advanced topics like path manipulations. So this is somewhere where we are influencing the incoming path. Okay, using AS path. So how do you add the AS prepending and how do you make the secondary link get activated and what needs to be observed? Then we have influencing the inbound traffic using MED, multi-exit discriminator. See, this is the lab diagram which we consider for this topic. Okay, so very detailed. If I go into this, it will it will not never stop. So this is Encore NRC topic. Once again, I just repeat for someone who just joined bit late. So this is what Encore and NRC workbook would look like, and this is the topology that you get it. This needs if in case you need to run it on your home lab, it will need minimum 16 to 25 GB of RAM and 6 to 8 core of CPUs. Okay, so I think it will show some status here. See, as of now, I've not powered on anything, but I've given it a high resource on our server. But at your side, you can have it between 8 to 12 core. The RAM, you can keep it somewhere 25 GB or 20 GB and storage. But don't worry, as I told, you get the remote access lab. You can take the MSTC or RDP and get connected to our lab. Simple as that. Okay. And I was also showing you guys about the DNAC. Okay. The DNAC process. So I'll show the DNAC deployment on the EXI. See, this is how the configuration would start. Okay. So if I don't want IPv6, then I go to skip mode and then start with the IPv4. I configure the enterprise interface and then I go to the cluster, give an IP, and then get it to the graphical dashboard of the DNAC. Once I get to the dashboard, then I'll show you how do you onboard. So on the DNAC, what is the purpose of DNAC, which is now called Cisco Catalyst? DNAC was the older name, but most of you guys are familiar calling it DNAC. It's called Cisco Catalyst now, and it's a controller that we use in the SD access. So we will see onboarding of Cat 8K router. We will see how to push the configurations. We will see how the iOS upgradation is done. We will see how the site hierarchy has been configured. We will see the we will see uh we will see the Jinja velocity. Okay, and the static lines of config that you can push. We will see the integration of DNAC versus Cisco ICE. Very important topic because this topic is also being asked in the CCI security. Okay, so this is something which comes in both security and enterprise. And so this is also a topic which comes under the DNAC and some more use cases of DNAC and other production scenarios of DNAC. But nowadays DNAC is heavily used for upgradation and site hierarchy or the configuration. And also we can use DNAC to upgrade. Let's say if you have 1,000 eyes agents, okay, via the Docker method. So DNAC is heavily used these days because this is a solution for your traditional management of devices, right? People don't want uh, to deal with devices standalone. So you need a controller to handle all this end devices. So for this is especially for the network. But as also you know that enterprise also has something for WAN side. So for WAN side, we have the SD. And if you guys to check the, let me show you, might be here. This is how our SD-WAN topology would look like. This is the topology. Okay. So it has the different type of controllers, VHS. These are sites basically where you have VHS connectivity. These are the carrier transport, MPLS, LTE, and internet. The workbook of this is separately kept as we have for Encore and NRC. And also for the DNAC, I'll be giving you the workbook. Okay, and finally for the CCI EI practice set, this is what it looks like. Give me a second, let me pull that.